We're going to go and review it real quick here. And remember the chant. I won. Negatives in the middle. I won. Negatives in the middle. So you just got to remember I won, negatives in the middle. Okay? Yeah, I won, negatives in the middle. We actually multiplied these together, Houchins. So, when you take I, you just have I. When you take I times I, that will give you I squared, correct? That's where that I squared is. But I is equal to the square root of negative 1, correct? That's what it is. That's the definition. I is equal to the square root of negative 1. Can you tell me what the square root of 2 times the square root of 2 is, Houchins? 2. What is the square root of a smiley face and times the square root of a smiley face? Smiley face. Okay? So, in this case here, Houchins means if I take the square root of negative 1 times the square root of negative 1, what would I get? If I take the square root of 3 times the square root of 3, what do I get? All right, guys. Square root of 3 times square root of 3 is what? What's the square root of a triangle times the square root of a triangle? What is a negative triangle? The square root of a negative triangle times the square root of a negative triangle. How are you getting it to be positive? Thank you, Miss Weekly. Flag on the plate. It is negative square root, a negative triangle. Guys, what I have, guys, when I have a 3 and a 3, I didn't change the sign here. Correct? I didn't change the sign here. I didn't change the smiley face. I didn't change the triangle. I'm not changing the image. So the answer to this is negative 1. So I squared is equal to negative 1. What is the square root of negative 1 times the square root of negative 1 times the square root of negative 1? What is 2? That makes that what? That's a negative 1 times the square root of negative 1, correct? But what does the square root of negative 1 really represent? What letter? That's I. So that's a negative I. That is where that one comes from.
So in the top one, is it basically just I times I?
Mm-hmm. Correct. This is I times I, so I squared is negative 1. So Houchins, what is negative? What is I times I times I times I? What's 4 of them going to be? Okay. That's what that one is. But this is the square root of negative 1 times the square root of negative 1, which we know is what again? Negative 1. What's the square root of negative 1 times the square root of negative 1? That's what?
I.
So what's negative 1 times negative 1? Multiply, hun. Multiply. Gives you 1. I is equal to the square root of negative 1. I squared is equal to negative 1. If I have 5 i's, guys, 5 i's, it gives me another square root of negative 1, correct? 2 of them we know is negative 1. 2 of them we know is negative 1. When we put those together, it gives you a positive 1. So now I just have another square root of negative 1 sitting here. So what is 1 times the square root of negative 1? It's just I. That's where that I to the fifth is. So let's say I put 1, 2, 3, 4, 5, 6 I's together. The first two we know are that, right? Which create a positive one, correct? Now this one here was that one, so I've got another square root of negative 1 here. So now I have another pair of square root of negative 1s, which is negative 1. So what's negative 1 times a positive 1? Negative 1. That's where the I to the 6 is equal to negative 1. So this pattern is I, negative 1, negative I, 1. I, negative 1, negative I, 1. We can continue, and that pattern will go on forever. And so the easy way I say it's just I, 1, negatives in the middle, so you can remember all four of them. Okay? And that's the continued pattern it would be. I, negative 1, negative I, 1. You just continue that pattern over and over and over again. Now, so anything you see that has a power that is higher than just a single object. So if I have an I to the 18th power, or 36th power, or 4th power, or 3rd power, or I squared, I have to convert it into one of the four things. All right, so you only have 4, and the 4 are what again? I1, negative in the middle, or I, negative 1, negative I1. You know those 4, then you can fit all of the other ones. Any power that you have, I to the 21st power, I to the 33rd power, you can change them into one of those 4. You have to change them into one of those. All right, you cannot have a power higher than 1. So in this case here, 18, there's a couple ways you can do it. You can count them like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That would put that as negative 1. So that's one way of doing it, Houchins. You just count to 18. Okay? Now, the other way of doing it is, I know I divide by 4. These are in groups of 4, correct? So how to that group of 4? This would have a remainder of 1. That would have a remainder of 2. This would have a remainder of 3. This would have a remainder of 0. So I take 4 and I divide it into 18. And 4, so here it goes 4 times. That gives me 16. I subtract, I get 2. So my remainder is 2. So that is a negative 1. You can do it that way.
So we just divide all this.
There you go. 36 divided by 4 goes what? And the remainder of 0. So that makes it what? 1. 17. What's the remainder in 17? 1. So that makes it I. 43 divided by 4 into 43. Remainder's 3. So that's just negative I.
That's literally all the way through.
Correct. You change it like that. Now, if you don't like dividing or doing long division, you can do what? You can count by 4s. You can count by 4s. So on this last one here, this is like 4, 8, 12, 16, 20, 24, 28, 32. So you can make a list if you want to. And this is where all the zeros are. So anything above that. So I can look, 36 and 40 are on this list, right? So that's probably all I need. So in this case here, I have 40, then I have 3 left over. 1, 2, 3. So that's just negative. So what if I have, I don't know, I to the negative 87? Well, I know 40's on here. I know 80's on there, leaving me just 7 left over. So then I can count 1, 2, 3, 4, 5, 6, 7. So that would just be negative I. Okay? So in this case here, you can easily count if you wanted to by using those. If you wanted to, 40s, 20 is probably all you needed to go because you go 20. 20 would go into 87 4 times, leaving 7 left over, and then I can count to 7. Okay? You can subtract it. All right? If I put a number in front of that, 187, 2187, it wouldn't matter. Because 2,000 is divided by 4 and 100 is divided by 4. So I can make these numbers as large as I want to the right. I can just keep adding numbers over here. It would make a difference. I'm really looking at the last two numbers. In 43 and seeing how they have 44. So you can ignore everything else. So if you're in the hundreds, it doesn't matter. Okay? So that being said, let's go through here real quick. I'm going to rewrite this using I, the letter I. So that makes that just 3I. This one is I root 12. Then I got to take 12 and break it down to 4 times 3, which is 2I root 3. 25. 5I. Now we have a binomial. I plus 9I. Now remember, you have to write it as A plus or minus BI. So the I has to be on the right side. So the right side's where your imaginary number is. Why is that? Well, remember our rational numbers? I told you earlier we have to write these like this. Our square root symbol is on that side. Well, what is I? The square root of negative 1. So I is also on the right side. Just to follow the same format, that is the way we write this. Okay? So your real part would be here. Your imaginary part would be here. 8 breaks down to what? 2, 2, 2. There's a negative there. So that's going to end up being a pair of 2's is going to come out and join that 2 in front, which makes that 4. The negative turns into an I, and I get root 2. So 5 is that. Number 6 is written in the wrong format. We need to rewrite this as negative 7 plus the square root of negative 24. 24 breaks down to like 8 times 3, 2, 2, 2, 3. Don't forget there's a negative. So a pair of 2's come out, gives me 2I root 6 with a negative 7 in the front. So that would be my answer for number 6. Now, your test on Thursday will not have imaginary numbers on it, okay? Though, however, we are going to continue doing the imaginary numbers here today and tomorrow.
Is it like a 40?
Yes, a full 100-point test. It can really change your grade. If you did well on the quiz, you need to know how to do a calculator problem, and solving are the only other two things we got to do. So let's get through these so we can get into practicing some of the problems that are on the test. Or I should say, review for the testers. All right. So, guys, notice this sign right here. Notice this sign right here. I have a lot of students who don't know what that sign means when they get on the test. That sign is addition or subtraction. But this is what happens, Peyton, a lot of times. I have people who multiply this times this, and this one times this one. Do not be that student. Take a look at your parentheses, see if there's a number in between. If there's a number in between, then that means we have to subtract these, which means I have to distribute the negative sign first. I'm going to rewrite this as 2 plus I minus 3 minus 1/2 I. If this was 2 plus x minus 3 minus 1/2 x, Miss Mary Beth, what would you do on that problem? Yeah, you would combine. That's good. That's exactly what I want you to go for. You would put that together, and you would put your x's together. You would combine your like terms. There is no difference in this problem than the i's. The I is just a variable. The only thing that is different is that if you end up with an I with a power, you've got to convert it into one of those 4 right? To the I, -1, -I, 1 situations, okay? So in this case here, this one doesn't have anything to do. We just got to combine our like terms. What is 2 minus 3? That's just a -1. And now I got to put a 1I minus 1/2. And what would you have to do to this one? How am I going to put those together? What do I have to do with the I? There's only one I. One whole I here minus half an I. I got to put that 2 over 2. See, Addison? So I had to convert that to me a well-chosen one here. So I got to choose that one so I can subtract these. That ends up being what? Yeah. There you go. That is my answer. You cannot remove the fraction out of this problem. The only way that could happen is if that was an equal sign, then you could do something like that. We can't do that. We don't have an equal sign. You cannot remove a fraction. All right, so looking at number 2, Houchins, what would you start with? We're looking at that one, Houchins. All right, so that gives me 2 minus 8I plus I squared. Now what? Stella, do you know what to do? Correct. This cannot be written. It's got a higher power. So I go I1, negative in the middle. And so therefore I know that this one is 2, so this one is that one right there. So it's I squared is really -1. So that's really a -1 in there. Then I can put the 2 and the -1 together to get 1 minus 8I, and there is your final answer for that problem. Number 3. Well, I don't really need those. I know there's parentheses there, but when I distribute a plus sign, nothing changes. So I can get rid of the parentheses and just really look at this problem for what it's worth. I can put my 2/3 and my 1 together. What is 2/3 plus 1? Don't tell me 1 and 2/3 because, I mean, that's right, but it's wrong. 5/3. 5/3 is correct. Then I have to take what? Minus 3I plus 1/2 I. Again, don't give me -2.5 I. It's not right. I got to make that a what? The whole into 6 halves. So I can get minus 5 over 2I. That is your final answer for number 3. Questions? What's wrong with number 4? Yeah, those square roots can be written as what? 5I. Now we threw this negative in here to throw you off. We throw that negative in there. We throw all these negatives in there to make you sick of negatives. What can you do with this negative? So that really gives you what? Plus 2 and plus 6I. So what happens when you put these together? The real part is what? 2 and a 3 is their real numbers, right? So that's 5. Well, how many imaginary numbers do we have? Plus 11i. There you go. So let's get these last two in. Then we can get into set 3. We'll talk about a calculator problem. All right, so this negative sign, it makes that -6 plus 3i, correct? This has 1/2 plus 4i. So what are you going to put together? I'm going to put together the half and the -6. And what will that give you? Don't give me -5.5 because that's not right. But it is, but it's not. I got to change this to what? 12 over 2. So I can make that happen to be -11 over 2. How many numbers, how many i's do I have? 7i. What is wrong with number 6? See that, Peyton? What's wrong with it? Yeah, they're not simplified. Remember, in that case there, we cannot have a 6, a 7, or an 8. Okay, so we've got to remove those. So we are going to, in this case here, count 1, 2, 3, 4, 5, 6. So this is really -3. Do you have any questions on how I got -3? Because I to the 6 is a -1. I to the 7th, 1, 2, 3, 4, 5, 6, 7 is -i. So this is -7i. 8. 1, 2, 3, 4, 5, 6, 7, 8. That's just 1. So this makes that just +2. I can put these together and get -1 minus 7i. You will see problems like number 6 on tests and quizzes, okay? So be prepared for that type of stuff. First,